being in a lab was a completely scary thing. Beneficial, but scary. I think being in that situation where you're a learner again, and being in the shoes where you're like, I don't know how this works. I see all the shiny buttons and I want to push them all, but I don't know what they do. It was literally like being my 14-year-old students again.
A lot of the techniques I ended up using I hadn't done since college. So I know that whenever I'm presenting something new to my students, I know that they can be a little intimidated, a little nervous, a little scared.
Once they get comfortable with being wrong or being partially correct, they really start to think through, well, why did this happen this way? How could I fix it?
Science is, we ran this experiment, here's what we found. What did we really find? What does this mean? And then we discuss that and we apply it to new situations. And so that's what I try to model my class more like.
To do more inquiry-based, so they have that opportunity to fail, and failing is okay because you learn more from your mistakes than you do from the successes. So if they just followed a set of instructions and did it, they're really not learning anything from it.
In my first couple years of teaching, I think I was a lot more, this is what the answer should be, let's do the correct steps so we get at that correct answer.
I really try to instill an environment with them that it is important, not just okay, important that we get questions wrong, so that we can talk about it and really learn from it.
I found my students get a lot more out of running an experiment and getting the answers wrong, or having a wrong procedure per se, and discussing, where did it go wrong. They get a lot more out of that than me saying, all right, here's how you should run your experiment, here's what you should get out of it. If you don't get that, you did it wrong.
If you look at like Common Core, any of that stuff, it's not a simple yes or no answer. It's just not rote memorization. You have to be able to explain it in detail, and you have to be able to understand it in order to explain it. So in the labs, they're not just going through and filling out answers and just putting data down and graphing it. What they're doing is they're having to interpret their results, figure out why that happened, why it didn't happen.
I found that I'm more excited about science, I tend to have more fun with it, and I also kind of let my guard down a little bit more, and I let the students discover more.
It's just a great way to challenge yourself, a great way to be more comfortable with doing inquiry. You're doing research, you're doing full inquiry, and being more comfortable being able to bring that to your students.
It reinvigorates you as a teacher, and you realize that there's so much more out there. I learned so much over the past 2 years that I couldn't wait to get back into school and share it with the kids.
It gets you excited about science, and you really bring that back into the room, and that's important for your students.
We can say that this is what's going on, you need to know this, and this is the reason why, because I just did this for 2 years. You're going off to college, you're going to do anything science STEM related. These are things that you need to know.